I'll share the screen. Right, did you see that PDF file?
Yes, sir.
So how is it? 11th standard level, is it okay or?
It's okay, sir, but I didn't understand exactly what a radian is.
Fine, okay. Let me open that file. See, there are two ways of measuring the degree, right? Sorry, the angle.
Sorry?
Hold on. See, angle is the region between two lines, right?
Yes.
So that region is proportional to the arc length. If I draw a circle, okay, between those two lines, some arc length will be there, no?
Yes.
Like if you take two lines, say these two lines, okay, take this line and this line. Between them, if you draw a circle, then this is the arc length which is in between those two lines, right?
Yes.
So if that arc length is more, then the region is more. If the arc length which is being between the two lines, if that is more, then the region is in between the lines is more, right? They are a proportion argument.
Yes.
Okay, so the full, if I take the full circle, what is the full arc length? Circumference?
2 pi.
2 pi r.
Yes.
Okay. So for that is corresponding to 360 degrees. Okay, so
Yes.
the arc length between these two lines, which is making angle theta, is theta divided by 360 into 2 pi r. Okay, and 360 degrees corresponds to 2 pi radians. We can have one unit another. So like 10 centimeters is 1 meter, right? Sorry, 100 centimeters is 1 meter, right?
Yes.
So similarly, 360 degrees is 2 pi radians. This is by definition.
Okay.
360 degrees, in terms of radians, it is 2 pi. This I can say it's by definition. And why is this a good definition that I will come to know later. Okay.
Okay. Yeah.
From this, I can get 1 degree as 5 by 180 radians. Basically, the full circle, if I divide it into 360 parts, okay, one part is 1 degree, right?
Yeah.
So now I divide into 6.28 parts. That is 2 pi radians. Okay, then each part will correspond to 1 radian. Or another way to just think is 360 degrees correspond to 2 pi radians. Like 100 centimeters corresponds to 1 meter. You don't question that, right?
Yes.
So similarly, just accept this one. One full circle,
Okay.
2 radians. From that, we get the conversion between degrees and radians. 1 radian is 180 by pi degrees. So approximately 60 degrees. Exactly is 57.16. Okay. So this is one important result. The arc length is r into theta, where theta is in radians. Okay. So if theta equal to 1 radian, then what is the arc length? If theta is 1 radian, then the arc length is r from here. theta is 1 radian. So you just have to put theta equal to 1. For
Yes.
this, in this formula, theta has to be in radians. You cannot put in degrees. Okay, when you put in radians, this formula is valid. So if you put theta equal to 1, then L is R, so the arc length is 1 radian. So if you have a sector of this angle is 1 radian, then this arc length is R. So this is R, this is R, and this is R. Got it?
Yes.
Okay. Now if you have an equilateral triangle of sides R, R, and R, what is this angle?
60 degrees.
60 degrees. But here, if I draw a dotted line here, okay, and make it a triangle, so that length of that dotted line will be less than R.
Yes.
180 is less than 60 degrees then, little bit less than. So the difference between the line and the arc is small, right? This is the uh, side length, okay, and it is little bit less than R. Okay, not very much because it's difference between this curve and this line. If the curve is big, then the difference between line and curve will become large. But since the arc is small, then the difference is approximately less. So this 1 radian is less than 60 degrees. And it's exactly equal to 57.16. Just to remember that 1 radian is close to 60, you can have this equilateral triangle and this arc length is R, so the side of the triangle will be a little bit less than R. So when it's a little bit less than R, the angle will be a little bit less than 60. Just to remember that 1 radian corresponds to 60 degrees approximately, and it is less than 60 degrees. The exact value is 57 degrees and 16 minutes. Is it clear?
Yes, sir.
Okay. So radian is just another way of measuring the angle. And you just have to remember that the full circle corresponds to 360 degrees and the full circle corresponds to 2 pi radians. And 360 degrees is equivalent to 2 pi radians. From this you can get 180 pi is pi radians. So from this you can get the conversion factor as 180 by pi or pi by 180. So whatever angle is in radians, the value will be small. When the angle is measured in degrees, its value will go. Like 1 radian is corresponding to 57 degrees, right? Like full circle is 360 degrees. In radians, it's 2 pi. 2 pi is approximately 6.28. So 6.28 is corresponding to 360 degrees. So in terms of degrees, the angle is more. The value of the angle is more. In terms of radians, radian is a big unit. Not like kilometer is bigger than meter. Kilometer is bigger unit than meter, right? 1,000 times. So similarly, radian is a bigger unit compared to degrees.
Yes.
Okay. This thing I understood sin square plus cos square equal to 1.
Yes.
Comes from the Pythagoras theorem.
Yes. I got that.
But this is, I can prove for theta being acute angle. Only when theta is less than 90, you can form a right angle triangle.
Yes.
And sine, cos, and tan are defined like this, opposite by, okay. And this is again
Yes.
definitely valid for acute angle. Okay. So now I have to generalize this definition when theta is greater than 90 degrees. Okay. So when theta goes to 90 degrees, the definition of cos theta is x by r. Since it's x, sometimes x is being used for angle. So instead of x by axis, I can take x1 also. Okay, here x is same as x1 and theta 1. Okay, so basically cos theta is x by r. Okay, this is the xy coordinate system, and this is the point here, x comma y. Okay, and it's the angle, it's making angle theta, the line joining the origin and the point xy. And it's a circle of radius r. So is this definition clear of cos and sine? Sine we have defined as y by r. That is same as opposite by hypotenuse, right? This is the right angle triangle. In this right angle triangle, y by r is what? Opposite by hypotenuse. So it is matching with the previous definition. Okay, similar tan theta is y by x. And x comma is the coordinate of the point, which is making angle theta with the x-axis. Right. So this is for acute angle. Now, if we take an angle theta one, second quadrant. So again, I'll define cos theta as x by r only, but that coordinate is x1. So it's x1 by r, y1 by r, and y1 by x1. Is this clear? The second quadrant. Clear?
Yes, sir.
Because in the first quadrant, I can draw a right angle triangle. Once theta crosses 90 degrees, there is no right angle triangle. Okay, so in that case, I'll just use this definition as x by r. Whatever is the x coordinate of the point divided by r, that I will take it as cos. And the y coordinate divided by r, I'll take it as sine. And tan is y coordinate by x coordinate. Similarly, the angle can be in third quadrant, theta 2. So cos theta 2 is how much now? The coordinate is x2, y2. So what is cos theta 2?
X2 by r, and sine is y2 by r. Y coordinate to second y coordinate by r.
Yeah, so sine theta 2 is
Tan
y2 by r. Tan theta 2 is y2 by x2. Okay, similarly, I can have in the fourth quadrant also. This will be theta 3. Okay, and this point is x3, y3. So same thing, x coordinate by r is cos, y coordinate
cos
is sine. So all
by r is sine and y by x is tan.
okay, and x square plus y square equal to r square. This is valid. We can use Pythagoras when it's first quadrant, but in other quadrants, this is equation of circle. You know circle equation? In order to learn circle, no? Okay, no problem. So just take this as sine square plus cos square equal to 1 for all angles, not only in first quadrant. Any angle, this thing is valid. Okay, just accept it. If you are not understanding it fully, you will understand it as things go on. Okay.
Okay, sir. Yes, sir.
Right. Now, yeah, from sine square plus cos square, you can get these two. This is obvious, right? I have already written here. Sine square plus cos square equal to 1. I divide both the sides by cos square. Start with sine square plus cos square equal to 1. Okay. And divide both the sides by cos square. I'll get this one. Tan square plus 1 equal to secant square.
Yes.
Ready for the next one? You have to divide by sine square. Because cot is cos by sine. Secant is 1 by sine. So from that you can get a guess that it should be divided by sine square. So divide by sine square, you'll get this one. Sine square plus cos square equal to 1, and these results are related. And you have to remember this one because you'll be using these things in the problems.
Yes.
Right. Okay. And once we say that sine is x by r, sorry, sine is y by r, now it says sine x equal to 0, x stands for angle. From that, we have to find the angle x. Okay, since x is being used for angle, for coordinates, I'll use x1. Not, I'll use x1 y1 coordinates, not xy. You just change your variable. It should not bother you. So instead of x0 equals L2, x1 y1 coordinate. So sin x is y1 by r. I have written here y1 by r, and sin will become 0 when what? Tell me.
If y is 0.
The y coordinate is 0, right? y1 by r,
Yes.
r is the radius of the circle. That's not going to change. When you move along the circle, only y will change. Y and x will change. So when sin
Yeah.
is 0, y has to be 0. Y will be 0 at where? These 2 points, which are marked as yellow here. This point and this point. These 2 points.
Yes.
So those 2 points correspond to which angle? 0 degrees, 180 degrees, and then 0 plus 360 degrees, 180 plus 360 degrees. In terms of radians, it will be 0, pi, and then you have to add 2 pi to it. Okay, so there are 2 angles, 0 and pi, and after that add 2 pi to it. So I'll get 2 pi, 4 pi, 60, because 2 pi is just making one circle and coming back to the same place. So coming back to the same place, it's same as the previous one. So here also I can add 2 pi and make it this one. And similarly, I can, these 2 points will correspond to 0 and minus pi also. The same, the angle of this point, I can measure in this opposite direction. Okay, when I measure in this direction, it's negative. Like the convention is that one, right?
Yes.
Anti-clockwise is positive. So this
And
angle is minus pi also. So angle
yes.
can be 0, pi or minus pi. Okay, and to this I can subtract minus 2 pi. This is like you are completing the circle in the opposite direction. This is like from here, again you go here, and then you come back here. Okay, it's minus 2 pi minus pi. Because the direction is clockwise. One complete revolution is clockwise direction is minus 2 pi, and then again minus pi. So it's minus 3 pi.
Yes.
Next will be minus 5 pi, minus 7 pi, like that. Okay, this for this point. Similarly, this point it will be minus 2 pi, minus 4 pi, minus 6 pi. All of them refer to this positive x-axis, x1 axis. Right? If you combine all these things, I just have to say theta should be n pi, where n can be 0, 1, because 1 is also there, no 1 minus 1 is there, 1, 2, 3, and also minus 1, minus 2, minus 3. So this is the general result, general solution sort of x equal to n pi, where n is any integer.
Okay.
Got it, no?
Yes, sir.
Okay. Similarly, sin x equal to 0. For cos x, what is cos x? In terms of y1, x1, x1 by r, right? It's a x coordinate by r.
Yeah.
So I'm taking x1 y1 so it should be x1 by r. So when will this cos be 0? Whenever x is 0. Right? And x is 0 at these 2 points, which are marked as yellow. These 2 points, x is 0.
Yes.
Okay. So those 2 angles correspond to pi by 2 and 3 pi by 2. 90 degrees pi by 2. Here pi by 2, 4 times pi by 2 will give you 2 pi. That is the original definition, right? The whole circle corresponds to 2 pi. So divided into 4 parts is pi by 2. So 1 quadrant angle is pi by 2. Is this clear?
Yes, sir.
So it is angle should be pi by 2 or 3 pi by 2. And after this, we can add 2 pi to it, because that's completing one circle and coming back to the same point. Okay, so it is pi by 2 plus 2 pi, that is 5 pi by 2, right? We add 2 pi to it.
Yes.
Okay, the basic solutions are pi by 2 and 3 pi by 2. After that, I add 2 pi to it. So there's this one. So this will become 5 pi by 2. Okay, so this if I add 2 pi, so 7 pi by 2. Right? So next will be 9 pi by 2. Okay, so 2 pi is actually 4 times pi by 2, right? 2 pi is equal to 4 times pi by 2. Okay, so already 5 pi by 2 is there. So next I have to add 4 times 6, so it will become 9. So 7 plus 4 is 11, like that. Okay, so if I want to combine all these things, it will become 2n plus 1 pi by 2, where n is an integer. If you put n equal to 0, I'll get pi by 2, and n equal to 1, I'll get 3. This one, and then next I'll get 5, 7. It's odd numbers. Okay, even numbers are not there. Okay, similarly, I can go on the negative side. Minus pi by 2, minus 3 pi by 2, minus 5 by 2, minus 11 pi by 2, like that. So that's why the general solution is 2n plus 1 pi by 2, and n is any integer. For any number, 2n plus 1 is odd number, because 2n is even. So the even number, if we add 1, it will become odd. And actually, it's the odd is, yes, 1, 3, 5, 7, like that. Okay. In the sign, this thing is both odd and even. It's 1, 2, 3, 4, 5, 6. So everything is covered there. For cos x, it's only the odd numbers. So 1, 3, 5. So there is a gap in between. 2 times pi by 2 is not there. 4 times pi by 2 won't be there. Okay. So that's why it becomes 2n plus 1 times pi by 2. Is it clear?
Yes, sir.
Okay, sine and cos has been defined. So from that, we can define new functions, cosecant x, okay, which is reciprocal of sine x. And secant x is 1 by cos x. Tan, you already know, sine by cos. And cot is 1 by tan x. Okay, and since we are dividing by something, this thing should not become 0. This thing becomes 0 at x equal to n pi. So that's why it's not equal to n pi. That's what you have got the result here. When x is n pi, sine will become 0. So that's why x is not equal to n. Similarly, cos, when x is 2n plus 1 into pi by 2, it will become 0. So that's not equal to tan. Again, cos is dividing. So whatever is the condition for this one, 1 by cos, same condition. It should not be 0. Similarly, for cot, x is not equal to n pi. Okay, so starting from sine and cos, we are defining other things. Tan is not an independent thing, it can be expressed in terms of sine and cos. So totally, 6 trigonometric ratios have been defined. This I already told you. Right. So basically, the angles, you know, right? Pi by 2 is this y-axis plus y-axis, and pi is minus x-axis, and 3 pi by 2 is minus y-axis, and 2 pi is x-axis. Right? That's where the angle means. Is that clear?
Yes, sir.
So from that, you can, once you fix the points on this coordinate plane, you know the sine and cos of that thing, because sine is y by r and cos is x by r. So for this yellow point, what is sine? This yellow point, what is the sine?
Zero.
Cos,
1.
that's what is here in this first this thing. For 0 degrees, 0, and tan is what for this yellow point?
0.
That's what is the first column. Got it?
Yes.
Okay, similarly, this positive y-axis, that for the pink point, what is the value of cos?
0.
So similarly, you will get these values. And if you quickly look at it, cos is 0, sin is 1, and tan is not defined because tan is sine by cos, and denominator is becoming 0. So that's why it's not defined. So this column is clear, 5 by 2 column.
Yes, sir.
Next is pi, and that is the blue point here. Again, check the values 0, -1, and 0.
Hello.
Yeah, you check this column for pi column, the values 0, -1, 0, sin is 0, cos
Yes.
-1. Why is cos -1?
Because it is goes to the
Negative x direction. So x is minus r.
yes.
R is the radius which is always positive. So this blue point, x is minus r, right? R is the radius. So this is
Yes.
so x will be minus r, and tan is 0. So simply 3 pi by 2, this point, okay. So that value is -1, 0, not defined. And 2 pi, the point is same as 0. So the first column will match with the 2 pi column, right? So
Yes, sir.
these are simple angles like 0 degrees, pi by 2, pi, 3 pi by 2, and 2 pi. They are on the coordinate axis. So, and we can take three more angles, 30 degrees, 45 degrees, and 60 degrees. For 45 degrees, we have to use this, we have to know this triangle. If you take a triangle of side A and side A, right angle triangle, what is the hypotenuse?
2 pi into a.
This
I
is
mean
Pythagoras
square of 2.
theorem.
Yes.
And what is this angle? And first of all, these two angles are same, right? Because it's
Yes.
isosceles triangle and this angle. So if you know this triangle, you can get this column. And you see the values, this column values you should get from this triangle.
Yes.
Okay. So there is one more triangle.
Yes, sir.
Yeah. One more triangle is this triangle. You take right angle triangle of sides 1, √3, and 2. Okay. Among 1, √3, and 2, which one is the maximum length?
2.
What is the value of √3?
Uh, 2 point something.
What is value of square root of 4? Square root of 4 is how much?
2.
And square root of 3 should be less
2
than
or minus 2.
that is fine. Square root of 3 should be less than square root of 4, right?
Yes.
So it should be less than 2.
Yes.
So what is √3, right?
1 point.
Okay, you should know the approximate value 1.732. So the maximum length is which length? 2, right? Maximum length is 2, right?
Yes.
So and maximum angle is 90. So 2 should be opposite 90. Okay. And the other two angles should be 30 and 60. And 60 should be opposite √3. And the 30 should be opposite 1. So if you remember this triangle, you can get these two columns. This one and this one. And you just check. Done.
Yes, sir.
Even for 60 also, 30 and 60. Okay, so in addition to the points in the coordinate, this one, you have to remember these two triangles, this one and this one. If you remember these things, you get all the values given in the table. Okay,
Yes, sir.
this thing you already know. This you understood also. All silver.
Yes, sir. All silver teacups.
Domain and range of trigonometric functions. The example I gave is y equal to root x. X cannot take all values of real numbers. There is some restriction on the x values, no?
Yes.
It should be positive, real positive. Okay, so the values of x for which the function is defined, y is root x, and this is a function of, this is equal to f of x. So this is called function of x. So this function is defined for not for all values of x, but for subset of it, and that is here in this case is real question. And this set is called domain. Domain has a set of values of x for which the function is defined. Got it?
Sorry, sir. Could you please repeat that? Your voice actually broke.
Domain is the set of values of x for which the function is defined.
Okay, here.
This function is not defined for negative x, right? So negative x is not part of the domain. Only positive values are part of the domain.
Yes.
This is the set of values which y can take. Y can be either both positive and negative. Y can take all real values. So range is real number line. Okay. And if you take another function y equal to x square, this function y equal to x square, there is no restriction. Domain can be the entire real line, and range is also the entire real line.
Yes.
Okay. So similarly, in the case of sine, cos, and tan, are there any restrictions to the domain? For example, take y equal to cos x. Okay. Domain, is there any restriction? The angle can be negative. Negative angles,
Yes.
you just have to go in the clockwise direction. And it can be any value because you just have to go that many circles and come here to that point. The domain is the entire R.
Yes.
No restriction. What about range? The values the y can take.
It can take positive and negative.
It cannot be more than one.
Mm,
Why it cannot be more than one? Because it's adjacent side by hypotenuse, right?
Yes.
Adjacent side is always less than one. Okay. And the general definition is x1 by r1, and x cannot be more than r. It is always less than r, less than or equal to. That is why the range is -1 to +1. It can go to negative, like you have seen here, right? Cos will be negative here. So it can go to negative. So
Yes.
here it will be -1 on this axis. So the range is this one. Similarly, we can find a defined range for sin x, tan x also. Sin x, again the same thing. Domain is R. The range is -1 to +1. What about tan x?
Mm,
Tan x, y equal to tan x. Domain is what?
real number.
Tan is y1 by x1, right? Tan x,
Yes.
right? Okay, so domain, is there any restriction?
No.
Okay, is the entire real line? What about range?
-1 and 1. +1.
Not really. It's y by x, no? So at this point, y value is something, right? But x value is very small. So y x will be very large. Okay.
Yes.
And as you go closer and closer, it will become infinity. Okay. And at this point,
Yes.
y is same but x is negative. So it will become minus infinity. Okay. So the plot of tan x will be like this. This is at 0 degrees is 0, and at 45 it is 1. Okay. At pi by 2, this side is shooting to infinity, and this side will be minus infinity. Okay. So range is again the entire real line. Okay. There is no restriction on tan, domain, and range.
Yes.
Okay. There is only one restriction because it's not defined at pi by 2, right? At points like pi by 2 and this on the y-axis, it's not defined because it's shooting to infinity and minus infinity. So we have to remove those points. In generally, we can put 2n plus 1 pi by 2. These points should be removed from the domain. If you put n equal to 0, I get pi by 2. N equal to 1, I get pi by 2. No, n equal to 1, I get 3 pi by 2. And then 5 pi by 2, like that. Okay.
Yes.
And if you say n is integer, you get minus pi by 2. N is element of integer, then you will also get minus pi by 2. N equal to minus 1, this will become minus 1, so it will become minus pi by 2. But basically, these 2 points, they should not be included. This point and this point should not be in the domain. So that's why this part is coming.
Yes.
This is the idea of domain and range of a function. This is the next class. Okay, yeah, I summarize this one. Domain and range. So sine, you can quickly see it, right? Domain is this one. Y is the range. And you just check for all the 6 functions. Is there any confusion? Sine, cos, tan is done, right?
Yes.
And cot, the point should not be on the x-axis and positive negative x-axis, because on positive x-axis and negative x-axis cot will become infinity, because cot is x by y or x1 by y1.
Yes.
Another way of understanding is cot is cos by sine, so whenever sine is becoming 0 and sine will become 0 to n pi, so that's why x is not equal to n. Similarly, cosecant x is 1 by sine, so x should not be n pi. There will be restriction on the domain, and the range will be opposite of what is, because the reciprocal of sin x, right? So do you understand that one?
Yes.
This one was the reciprocal of sine. Got this, no? Similarly, secant x. Done?
Yes, sir.
Right. The plot of sin x will look like this. Definitely, these points you will know. At pi by 2 it is 1. At 0 it is 0. Pi also is 0. Okay. and 3 pi by 2 will become -1. At 2 pi, these values, it's obvious. Okay, so between 0 and pi by 2, y is constantly increasing. Y in the sense y1. I'll just draw the picture. The first quadrant, this 0 will this pi by 2, right? As this thing moves this way, y is increasing, right?
Yes.
Y is increasing, sin is increasing, because sin is y by r. So that's why it's from 0 to pi by 2, this thing is increasing. Sin is increasing. Okay, and after this point, if you move like this, y is dropping down, right?
Yes.
And here y becomes 0. Okay, so this dropping down part is this part. This is the second quadrant. Second quadrant, so pi by 2 to 180, pi by 2 to pi. Okay, and once reaching here, again y is going to increase. Right, it's going to increase uh, in the negative.
Negative.
It will become more and more negative. Increase but negative. Right, that's what is happening here. The value is increasing, but it's becoming more and more negative. This is third quadrant. Understood, no? Here y is 0, after that it's increasing, right? But it's becoming more and more negative. Yes?
Yes, sir.
Understood?
Yes, sir.
And from here to here, y is going to decrease, but still negative. You just forget the sign. If you forget the sign, y is increasing, right? Sorry, y is decreasing. And that's what is happening there. Y is decreasing, and that's why y is decreasing, but it's negative. This is the fourth quadrant. And after fourth quadrant is this one is repetition of the first quadrant. This one is whatever has happened in the first quadrant, the same thing will happen here. Because it's repeating, right? After one complete revolution is the same thing. That's why the period is period. Because after this it's going to repeat. Similarly, I can go on the negative side. If you go on the negative side, y is what? Increasing, right? Even though it's negative. And that's what is happening here. Y is increasing, but it is negative up to this point. Up to this point, after y is going to decrease. That's what is happening here. It's decreasing. And then after reaching here, y is positive, and then it's increasing. It's increasing. And then from here, y is decreasing. Y is decreasing. So understood the graph, no? So minus pi means we are going in this direction. Right?
Yes.
I took it in the wrong way. We should have gone this way. Okay, not this way. We go this way. Again, the same argument, same logic. We just have to see how the y is changing. It's increasing or decreasing, and then you can put the sign later. Okay. Similarly, cos you can figure out. Start from 0. As you move like this, x is what? Increasing or decreasing?
It's decrease.
So cos will decrease. And at this point, what is cos?
0.
Cos is like x by r, no? X1
Yes.
is 1. So at 0 it is 1. After that is decreasing. Up to pi by 2. After that is increasing on the negative side. That's what is happening here. It's increasing but on the negative side. Up to this point. And again it is decreasing but on the negative side. This is decreasing third quadrant. And after it reaches here, again it increases on the positive side. Okay, so we have reached 2 pi. This much is one period. After that, it's a repetition. Okay, similar on the negative side, we go in this direction. Okay, cos will decrease, and still positive. So it's decreasing and then positive until you reach this point. It is 0. Okay. After that, it is uh, increasing but negative. It is increasing but negative.
Yes.
From here to here, this part, and then from here to here, this part. So this was just one period. Okay, this is where I understand the sine curve.
Yes, sir.
So similarly, you can figure this out. Tan. Will you do this on your own? I'll just give a brief idea. At this point, what is the value of tan? Tan is y1 by x1, right? This is x1 axis, this is y1 axis. Tan is y1 by x1. At this point, what is y1 by x1? Zero. Y1 is 0, x1 is some.
0.
That's why
Yes.
you get this point. Okay. And when you do like this, y1 is increasing. Okay. And x1 is decreasing, right?
Decreasing. Yes.
So y by x will increase then. And that's what is happening. Y by x is increasing. Tan is increasing. Okay. And at the middle, that is at 45 degrees. Middle is 45, right? This quadrant is 90. The middle is 45. At the middle point, y and x are same. The equation of the line y equal to x makes an angle 45 degrees with the x-axis. So at this point, 45 degrees, the value of y by x is 1. So this 1 corresponds to 45 degrees. It's in the middle of pi by 2. Okay. And after this thing, y increases, y1 increases, and x1 continues to drop. Okay. But here x1 will become very, very small. So that's why it shoots up to this infinity. In this small part, it will go from 1 to infinity. And that's what is happening here. Okay. And after reaching this point here, it is y by x is minus infinity. Here it is plus infinity just before 90 degrees. And after 90 degrees, y is positive, but x is very small negative. So it will jump to minus infinity.
Yes.
So that is why it is jumping to minus infinity. From here to here, there is a big jump. That is why tan is not defined at pi by 2. See, if there is a small jump at pi by 2, you can say it is middle of this, somewhere in the middle. Okay. But this jump is infinite to infinite on the other side. That's why tan is not defined at pi by 2. And once reaching this thing, again you can, y is decreasing, x is increasing. So the value will keep on decreasing. Forget the sign for the moment. Okay, just y by x, y is decreasing, y1 is decreasing, and x1 is increasing. Okay, so the value of tan will keep on decreasing. Okay, and the sign is negative because y is positive and x is negative. So this part until you reach this point where it is 0. After that, it will be like this because both y and x are negative, so it will be positive.
Yes.
Okay. So, right, one obvious period is from 0 to 2 pi. Okay, but within 2 pi itself, uh, it's repeating within a period of pi. This is just a period, no? This is just a period because this is the same thing that's repeating. Okay, and
Yes.
this period is pi.
Yes.
2 pi is an obvious period because it's going to rotate and come back to the same point. But in addition to 2 pi, there is a shorter period which is pi. Right. So you can figure this thing out on your own. It's not difficult.
Yes, sir.
And so then I'll touch the 11th standard portion, right? Your understanding.
Oh,
Whenever I discuss the 9th standard portion, after I finish that, I'll touch the 11th standard portion.
Yes, sir.
Because that will be more interesting. Okay. Fine. So these two you figure out. If you're not able to figure out, I'll tell you next time. Okay.
Yes,
Secant,
sir.
secant you can think as 1 by cos. So it is r by x, r1 by x, r by x1. Okay. From that you can get this idea how it is varying. Similarly, cosecant is 1 by sine. So tomorrow onwards, you have to check your email ID, email, and then use that Zoom ID, meeting ID. Okay.
Yes, sir.
No Skype.
Okay, sir.
Skype is not required. Okay, then see you tomorrow.
Yes, sir. Okay, sir. Thank you, sir. Have a good day.
Bye.